Hey everyone, how is it going? Welcome to Code Smart. My name is Obaida. I'm a software engineer at Facebook, and today I'm going to talk about this famous interview questions called number of islands. This is a leetcode problem, leetcode 200, medium type problem. And the problem states that given an m into n 2D binary grid which represents a map of ones, one is land and zeros, zero is water, return the number of islands. So here is an example. This is a grid and it has rows and columns or list of list, and it has some ones and zeros. So ones are land and zeros are water, and we need to find out how many islands are there. What is an island? An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. That means if it is outside of the grid, we can assume that those are waters. So let's check how popular is these questions. If you see how many questions have asked these questions in the past 0 to 6 months, we see that Amazon, Microsoft, Bloomberg, Google, LinkedIn, Facebook, Oracle, all those big companies are asking these questions. This is a very popular questions, and there are some other variations of these questions. It may come in this exact form, or there might be a slight variations, but the basic algorithm will be same. So let's go to my whiteboard where I will explain this problem and how can we approach this problem. After that, we'll come back to explain the code. So in this finding number of islands problem, we'll have a matrix or list of list or array of array where we denote land by 1 and denote water by 0. And we need to find out how many islands are there in this matrix. What is an island here? So island is like if we have a land and that land is connected to another land, either vertically, for example, this land is connected to this land vertically, and this land is connected to this land horizontally, then those lands belongs to one island. For example, this is another land and this is connected to this, and all those four makes one single island, and the other neighboring cell here is water. So this is water, 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 and water. So this four cell belongs to a single island. So we found one island here. And one thing we need to note here is, and a land can be connected to another land either vertically or horizontally. We cannot take into account if it is connected diagonally, like this cell and this cell has a diagonal relations, but will not take these like they are connected. So we'll only consider if it is horizontally connected or vertically connected. So that's how we define an island, and we can consider the rest of the matrix, like outside of this box are all water. So we can think this is water, water, and water. So this forms an island. And how can we solve this problem? One important thing to notice in this problem is like we're talking about one node is connected to another node, or one node is a neighbor to another node. So whenever we hear those buzzwords, so there is a possibility that this problem might be a graph problem. Because in graph, we have one node, then that node is connected to another node, that node is connected to another node. We have this parent-child relationship or the neighboring relationship. So whenever we hear those type of words or think about those type of words like the connections or neighbors, parent-child relationships, then we should think that this might be a good candidate for applying graph algorithm. So we can solve this problem using our known graph algorithm like the DFS or the BFS. We might apply the union find data structure, but in this video, I'm not going to talk about the union find. Maybe I will make another video on the union find data structure, the union find algorithm. But in today's video, let's talk about how can we solve this problem using either DFS or BFS. If you want to use any of this graph traversal algorithm, what we are going to do is we'll start our traversal from any cell here, and then we'll visit all the connected nodes, and then we'll mark them as seen. Let's see an example. Let's say we're going to start our DFS algorithm from this cell. So when we visit this cell, we mark it as seen, and then from this cell is connected, so we'll visit there and mark it as seen. This cell is connected to this cell, so we mark them as seen, and this cell is connected to this cell, we mark them as seen, and then from this cell is connected, but we're not going to visit that cell anymore because this is already seen. So in order to do that, what we can do is we can keep a set, let's call it seen, and whenever we visit a cell, we put that cell in this seen set, and anytime we need to visit another cell, we'll check, have you already visited that cell or not? If you have already visited that cell, we don't need to visit that cell again. Why? Because this graph is not an acyclic graph. It might form some cycle, like we can go from this cell to this cell, and again this cell to this cell, then again this cell to this cell. So it might end up in an infinite loop. So in order to avoid that, we must keep track of how many or which nodes we have already seen or we have already visited. And that's how we can avoid this type of problem with the cyclic graph. If we are allowed to modify or mutate our given matrix, then instead of keeping this set seen, we can just convert this land to water. For example, we can make it 1 to 0 so that we won't visit it anymore, and that's how we can save some space here. But let's stick to the simple solution this time. So this cell is not the neighbor of this cell because this is water, so we'll only consider two cells neighbor if both of them are land and they are either connected horizontally or vertically. So we got one island here, so our number of island is 1 until now, and then we can come to this cell. You might want to start another DFS from here, but we don't really do that because this cell is already in our seen set, so that means this is already visited, so we don't need to do that. Then we go to the next cell, but this cell is a water cell. We don't really need to do a DFS graph traversal from here because there is no way that this cell belongs to an island, so we can safely ignore that, and that's how we can optimize our algorithm a little bit. And go to the next cell. This is also water. We skip that because this is already seen. Skip that. Skip, and then we come here, and then we start another graph traversal, either DFS or BFS from here, and we mark it as seen, and there is no connected cell here. It doesn't have any neighboring land, so our DFS stops here. There is only one node, but it doesn't matter, we found another island, so our number of island will increase by 1 again. And then we go to the next cell. This cell, these are all water. We don't need to traverse those cells. We come here, so we found another potential node to start our graph traversal, so that means there is another potential island here. We increase our number of island by 1, and then start our DFS. This is seen, and then it is connected to this one, and then we go to this cell, and this is seen. There is no other way to get out of these two cells because this is water, this is out of the boundary, so our DFS stops here, and we found another island, so the total number of islands will be 3. So this is how, using a simple graph traversal, we can solve this number of islands problem. So let's go check the actual code. All right, so here's the solution in Python. Diff number of islands. We are given a grid, which is a list of string, and we need to return an int. That means how many islands are there in the grid. So at this line number 3, we're doing a sanity check. So if the grid is false, that means it doesn't have, it's an empty grid, then we'll just return 0. Or if the grid 0, so that means it has a list, but that list is again empty, so in that case we'll also return 0. So this is the sanity check we are doing at line number 3. At line number 5, we are defining two variables, R and C. R denotes the length of grid, that means how many rows are there, and C denotes the len grid 0, that means the first list of list, which is the number of columns. And then again we are defining another variable here, self dot scene. This is a set, and we'll put every node which have been visited in this set. And then another variable called res or result, we are initializing this as 0. And then this is a typical DFS. We're defining our DFS as an inner function here. So this DFS will get the row index and the column index. We're calling it R and C. And we'll run a DFS here. And then here, let's get back to DFS later. And here and this one, what we're doing is we're basically iterating through all the cells in this grid. So we're iterating through row, and then we're iterating through column, so that we are getting the row index and the column index, and we'll check if those cell is already seen or it is a land and water. Based on that, we'll start a new DFS as I explained in the whiteboard. Here is the conditions: if row call not in self.seen. So if it is not seen, then we can start the DFS. Also, we need to check this is land, because if it is water, then there is no point of starting a new DFS here. So whenever we can start a new DFS, we'll increase the result variable by 1, because we just found a new island. So every time we can find a potential row index and column index, we increase the result by 1, and then we start a DFS. And during this DFS, we'll visit all the cells connected to this cell, and we'll mark them as seen. So let's go to the DFS function. So this is a typical DFS function. We're getting RC, the row index and the column index, as our input here. And the first condition is R greater than or equal R. What does it mean is the row index is getting outside of the grid boundary, or the C is greater than or equal to C, the capital C. That means column index is getting out of the boundary. So we are given that if it is out of the boundary, then we don't need to do our traversal over there. Or if it is R less than 0 or C less than 0. So this condition is basically checking if we are getting out of the boundary or out of the grid. There is an OR condition here. We are checking if this cell is 0. So 0 is water. So if this is 0, we don't want to travel to that cell. Or if this cell is already seen, if we have already traveled this cell earlier, then no need to go to that cell again. As I explained in the whiteboard, that's how we solve the problem with the cyclic graph. We keep a set where we put all those seen nodes in there, and we check if you have already seen it or not. So if any of these conditions met, then we just return. We don't want to go further. And then if it doesn't, then okay, we travel to this cell and we add that cell index as a tuple. This is a tuple in our scene set. So we'll use a tuple because tuple is immutable, and we can use tuple in a set in Python. And then we will try to find out the neighbors. Who are the neighbors of this particular cell? And the neighbors are connected either horizontally or vertically. So we can go to the left, we can go to the right, we can go to top, or we can below one cell. We can take this 4 tuples. So 0, 1 means our row will be same, but we'll go to the next cell. Similarly, we'll go to the cell to our left, and we can go below this cell, or we can go up to this cell. And then these are our neighbors, or these are connected to the current cell, and we will run a recursive function DFS, and then we get our new row index and column index, which is R plus I and C plus J, and it will call DFS again. So it will come here again, and if it meets the conditions, then it will be marked as seen. If it doesn't meet the conditions, then we'll just return from here. So that's how we'll travel all the cells connected to this root node where we started, and then we'll mark all the cells that we have traveled as seen. And then we'll do this for all these row indexes and column indexes from the grid, and whenever we can start a new DFS, we'll increase the result, and finally that result will be our answer.